In this tutorial, you will learn how to create machine learning models using NextBrain and build a mixed market from them. This will enable us to predict and invest in different marketing campaigns. Please note that the data used in this tutorial is artificially created by NextBrain and not based on real-world data. In order to solve this context, our features are generally related to the total number of examples advertised on different factors, such as in TV, print or Facebook. Those have other features such as newsletter visits or Google search clicks. The main idea behind this task is to build a machine art model such that it can predict a thought of revenue after we enter different features like the total standard spent on Facebook ads, Google clicks and newsletters visits. This will enable you to utilize the machine learning model and receive an optimized mix strategy for your performance. Let's explore our data now. We have scientific data here. But as I mentioned earlier, the data is not real and is generated by NextBrain. Therefore, the data may not make sense by itself. We have datetime index. You can also see the data types for each column. We have this different amount of spent on different marketing strategies such as Facebook or lots of form or TV commercials. We also have a review of competitor sales. And finally, total revenues of our target values. We also have the correlation matrix. This will demonstrate the maximum of linear and non-linear correlation between its two features. We can say that we have set total revenue as our target feature, and it is clear that compared to other features, sales are the most strongly correlated with total revenue. You can always go back and see what sales competitor A has in this context, and see what points the competitor I sales in this context. Let's go back and explore this further. So competitor I sales of competitor are in this state. Basically, I think the best market experience for this page for a specific date. And you can also observe your data more complexity in this scatter plot. First, let's see how the Google search clicks behave with total revenues. We can see that Google search clicks number increase and total revenue does expect increase as well. So we also have total revenue here. You can always explore and dive more into your data on this scatter plot. Now, let's train our model. And we can see the previous train model. We can ignore that. So let's train the new model. Click the column to predict and select total revenues. This is a regression test, so we will try to predict a continuous value, and the main idea behind training is that we will give enough data to our model or enough level data to our model that we will try to find a pattern inside this model. It will basically utilize a pattern. For this instance, we will predict any total revenue based on different market features which our model is trained on. You may also try to ignore some columns. Let's say that print ad spend already isn't correlated to total revenue. So we may try to build a faster model, but we will not ignore any columns in this tutorial. You can also build different training and quality models. This time, we will build a performance quality. It means our model will be trained for about 5 minutes. We have also advanced optional. Let's add more synthesis data to our model. Because more data generally the better our model. We have a chance to build a more accurate and more inclusive model. And you may also try to play the train tested threshold or try to optimize other metrics, but we will set it as auto. So let's train our models. So this procedure will have to take 5 minutes. The training for our model is completed. As you can see, we have 68% accuracy. This isn't a great result. Check also this suggestion section. We are told to generate more samples. Although we add synthetic data, we probably needed to even add much more data to our model for more excellent performance. So we can also see the visual explains figure after that simple decision tree that splits a target variable based on some features, though if the newsletter visits greater than around 88,000. You can see that the distribution for our target table, which is revenue, is generally spread out around these values. But if it is less than, if the newsletter visits are less than this, so this is the total revenue for this decision to respect.
We have removed some columns, such as date and competitor A, sales, from the training history model as they resulted in poor predictive performance. We have also provided the original and prepared datasets, which have the same values. We did not drop any rows, but we transformed and scaled certain features to prevent prediction errors. We aim to maintain a consistent scale for all features to prevent outliers or large values from impacting the scaled predicted results. Scaling is one of the core and important pre-processing steps, and the next model automatically scales data as needed. The scaling procedure applied to the data is specified in the model training information. Additionally, the column imprints are scaled using natural logarithm. We can also see the similar to ratio of the synthetic data with the original data. It's very high, so our newly created data isn't or doesn't behave too different than our original data, and also we can see the partition. So let's click on the dashboard menu for more insight about our model. We can see the model accuracy metric for both training test sets generally have very similar values. Also, you can see the column importance and how each column relate to the predicted results in predicted feature. That's the total revenue. So we can see that this set of widgets apparently has the strongest correlation with the amid predict results. So if you change newsletter with it, it will give you a more outside, it will determine your mode of performance in more distinguished. So we also see that in the visual explains to the graph, so our model is splitted according to newsletter. It means the newsletter explain how the predicted result will be distributed. So you can see for instance that the Google source stand is on the second right, and then these are the generally lashly correlated with predicted results. You can also click the help icon for more detailed explanation about this. We have advanced statistics. So we have different metrics for both training and testing performances. We have mean absolute percentage error around 48%, which isn't a great model. We also have several other metrics you may want to utilize one over another dependent on your situation. In this part we have around 0.7, which actually isn't bad because it's relatively close to 1. And you may also try to compare how and what's your prediction versus what the actual value, so you can see that for this value predicted. So you may want to diagnose some very long predictions on this graph and try to find where your model is especially bad and maybe focus on that area for more expressed model. We have the Sankey diagram here. This is a flow of two predicted results. For instance, let's say that you know that your Facebook impression is 15. You will know the price, and you also know that the amount of money you spend on Google search is 160. So you will be on that section, and by iterating the same process for other features, you can and will be able to predict the total revenue just based on this value. So the same good diagram, but basically demonstrate it in a more fancy way. And we've already explained that visual explainability. Like what I said before, newsletter visits explain the predicted values. It gives the most reliable feature in terms of predicting the thought of revenue, so it is the distribution better. And finally we have the predicts bar. Here you can make new predictions after entering a valid values for each feature.